So had your coffee? Yes. Found another job? How many of you have found another job here already? Okay, as I say another job, I say we are trying something completely different with this talk.
Ooh.
So we're not only pure Java conference. And I'm very happy that we're going to talk not only about Java, but also about this amazing stuff called Dapr. And we have somebody who is actually very much involved in it,
Yep.
like Bilgin. And yes, who is still doing microservices? For money, I mean. Don't hesitate.
Wow.
Who is doing monoliths? Who is doing microliths? You know what microlith is? It's everything else, yes. So, and I think that, Dapr is an interesting choice for microservices, so that's why I'm really happy that Bilgin is here, and he's going to tell us how to do it the best way. So, Bilgin, thank you for coming. Go ahead.
Cool. Awesome. Thanks for the introduction. All right. I'm super excited to actually give finally a talk in my home country. So thanks for the invitation. I have one question though. I'm curious how many of you, I know you are all using Java, but how many of you are using also other languages? Maybe not you, but your company have other teams that are using Java with Python, Java with .NET, Java with other languages? Yeah, okay. Maybe 10, 20%, good. So in this talk, we'll see how you can create microservices in Java and also other languages, right? So I'm originally from Bulgaria. I studied computer science in Plovdiv. And since 2010, I've been in London. And I think I've done my fair share of Java programming. I've been committed to multiple Apache projects, such as Apache Offbeat, ISIS, Camel, Kafka, ActiveMQ, and so forth. So I've done quite a lot of Java. Then I start using more and more Kubernetes, right? And I have a book. If you go to this URL, katespatterns.com, you can actually get a copy, including a free copy sponsored by my previous employer. And more recently, I started working on Dapr at Diagris. And basically, we'll see in this talk what Dapr is and how it can help you create distributed applications in Java and any other language. To start with, we'll look in a couple of YAMLs, right? And we'll have a brief look into Kubernetes. And to guide this talk, I put together like a representative microservices architecture. I think this has the common elements of a microservice. Like you have a front end that talks to backend services through API gateway. In the backend, for this talk, we'll assume it is running on Kubernetes. So you have, shopping cart, checkout service. Most of these services talk to each other. Synchronous request reply. There is a message broker for asynchronous interactions. There is, of course, a couple of databases and even interactions with external services. And I would say one of the first things you will have to answer in that case, how can I run this beast, right? For example, how can I constrain services that consume lots of resources from affecting other services? How can I roll out those applications without breaking production? How can I configure them and so forth? And I think even for this audience, the answer here is no surprise. Today, the most common answer for operating large-scale distributed applications on-premise, on cloud is Kubernetes. So Kubernetes now is over 10 years old, right? 11 years old. And it lets you run distributed applications on, it puts them in pods and runs them on different nodes. I'm curious how many of you are using Kubernetes at work or deploying on Kubernetes? OK, maybe half, roughly. And I won't go too much into Kubernetes, but just to cover up the basics, so Kubernetes, while it's an operational tool, it has a number of capabilities that helps also with the applications, right? For example, it will use containers to constrain your application in certain boundaries. Then it will use that to place your application, so it can do bin packing. It will find the right node that has sufficient resources. While doing that, it will also, if you have any configurations, it will attach those configurations to you. It can do different kind of deployments, so it can do rolling deployment, restart your instances in a specific order. it can direct traffic to specific services and perform health checks and so forth. If you look into all of these capabilities, Kubernetes capabilities, we'll see that most of them are around the life cycle of your application, right? But if you have an application, whether that's microservice, monolith, it needs more than life cycle. That application will need to talk to other applications. So you need networking. That application needs to interact with different state stores. So that's the statefulness. The application will need to talk to different APIs using different data formats. That's connectors. And these are all the other aspects that Dapr helps with. Right? So Dapr doesn't do anything about the life cycle of your application, but it helps your application to do these other things. Then briefly, let's look into Dapr. So Dapr, it stands for Distributed Application Runtime. It's a CNCF project. So it's an open source project in Cloud Native Computing Foundation where Kubernetes is. And if you look at some of the statistics, it's actually super active. Today, it's among the top 10 top 10% projects there. It's around number 14 out of 150 projects in CNCF. It has over 30,000 stars, 4,000 contributors, etc. So if you're curious how active it is, you can jump on Discord where there are 8,000 people. And really, to understand Dapr, there are two things to know. The first one is Dapr APIs. And these APIs are basically capabilities that you can call from your application. For example, there is an API called service invocation that helps you to connect services with request reply. There is an API called publish subscribe that helps your applications to do asynchronous interactions, right? There is API called state management that lets you access different kind of key value stores and databases. These APIs in the Dapr world, in the Dapr documentation, very creatively, they are called building blocks, but essentially these are APIs. And I think there are over 10 today APIs. In addition to those APIs, you get cross-cutting concerns, such as observability, security, resiliency. We'll look into those. These kind of capabilities that apply almost like horizontally across all the APIs. That's the first thing. And second, and the last thing to know about Dapr is the concept of components. And you can think of those components as the implementation, different implementation for the APIs. For example, if you want to use the state management API, you have to pick an implementation. That implementation can be based on DynamoDB, Cosmos DB, Redis, Postgres, you name it. If you want to use publish subscribe API, you pick an implementation such as Apache Kafka or RabbitMQ or SQS SNS. And all of these implementations, they are within Dapr. You don't have to do anything to add. You only configure that implementation with a YAML file. So from a developer point of view, a component is a YAML file that you configure and you start using those implementations. And you see there are 100+ components today. Let's see how these two things come together. Right? On the left-hand side, you have the Dapr State API that shows a couple of operations, CRUD operations, right? For example, if you want to use the State API over REST or HTTP, you can see v1 state, that's the API, and then the name of the component. And on the right-hand side, you see the component definition, the YAML file I was talking. You give it a logical name. In this case, it's order store. And then you have a type, which says Redis. And after that line, there are Redis-specific configurations. This is the simplest version, like how do I connect to Redis that runs on Kubernetes in this case. And if I want to swap Redis to something else, okay, here we did it. As you see, nothing changed on the left-hand side. Your application doesn't change. Nothing on the API changes. We only change the component definition. Now it will be using Cosmos DB as its implementation, and you can talk from your application to Cosmos DB straight away. How does that look in practice? Let's say we are working on a couple of services represented by the different colors. Here I have 3 services. I'm running this locally with Dapr. Maybe for secrets, I'm using a local file with passwords. Then for PubSub between the services, I'm using Redis. And I see the third service there is also using some kind of in-memory state store. Right? If I want to move that application to Kubernetes, You don't have to change the application. Instead of local file on Kubernetes, you would be using Kubernetes secret. Sorry, in this case, actually it says HashiCorp Vault. You can use HashiCorp Vault, right? Instead of Redis, I'm using RabbitMQ. Instead of in-memory, I'm using Redis. So you can swap those. And if you want to deploy then on Azure, you can swap those to native Azure services. Like I can use Azure Key Vault for secrets and Azure Service Bus for PubSub and Cosmos DB for storage. And I think you get the idea. If I move on Amazon again, I can swap those to Amazon native services. And same for Google Cloud. So your code, your application doesn't change. You just give it a different YAML file, and the application becomes fully portable and independent. That's briefly what Dapr is. And at high level, you can think of Dapr as a process that runs next to your app. Your app can be in any language, really. You see at the top. From your app, what you have to do is you interact with Dapr over HTTP or using gRPC. And there are SDKs for these languages to interact with Dapr and use those APIs. Now, this raises the question, then what is Dapr? Is it a library? Is it a framework? Is it a platform? What is it? And the answer is it's none of those. It's basically a sidecar. It runs as a sidecar. That's probably the best definition. Now, sidecar is a pattern that was popularized by Kubernetes, but actually it started way before Kubernetes. I think probably one of the first famous sidecars was in Java. Netflix, they put their, I think, Hystrix and one of those libraries for network resiliency into a sidecar called Prana. And basically that was to make these awesome Java libraries available to other languages, right? They put that in a separate process that you can run to your application, and you can access those from other languages, like .NET, etc. And Kubernetes made this pattern much more easier, because now in Kubernetes, in your YAML file, this is how you deploy to Kubernetes, right? If you have, let's say, a Python app, you can easily add next to it a Java app, which would be, let's say, a sidecar. And then these both applications basically share the same life cycle. They are deployed together. They deployed on the same node. That means they can talk to each other over the networking. They can share storage, etc. This is how you would do a sidecar on Kubernetes. In this case, you see they also share a common volume to pass files. Now, you don't have to do all of that to add a Dapr sidecar. Actually, the only thing you have to do is, as you see there are two annotations you have to add to your application. The first one that says enable YAML, enable Dapr, right? And the second one is to give a unique ID to your application. With that, every time you deploy your application, you will get the sidecar running next to it, and you can start using Dapr. How does the sidecar get injected? First, you need to install Dapr on Kubernetes, right? Anyone who is operating your Kubernetes cluster, they would know how to install that, whether you would use a Dapr CLI, a Helm command, or an operator. There is like a couple of control plane services that get added to Kubernetes, and from that point on, you can deploy applications with Dapr enabled. How can you use then Dapr from your Java application? If you want, you don't need to have any kind of dependency to Dapr, right? You can use just the HTTP API of Dapr, so you can just do HTTP calls if you want. Or if you want, you can use the SDK. It's a single SDK that gives you more of fluent DSL to interact with Dapr. And you see there are other optional, Spring Boot integrations, Spring Boot starters. There is a Quarkus starter, test container integrations, IntelliJ setup, and so forth. And on the right-hand side is the simplest example. You instantiate the client, and you start calling the APIs I was explaining earlier. So that is really briefly what Dapr is. Now, I talked about the portability aspect, right? But that's not the only reason, right, to use Dapr. I would say once you have a couple of services running, the very first thing they will want is to talk to each other. And still the most common the most common way is to do synchronous request reply. And when you start doing that, you need a number of things. For example, how do the services discover each other, right? If they how do I encrypt the traffic between the services? How do I trace that? How do I make the interactions resilient, and so forth? And you can all do all of that with Dapr. Let's say, on this example, I have the shopping cart that needs to call checkout service. And rather than directly calling the checkout service, if you are using Dapr, what you do is the shopping cart calls the sidecar. And the URL that you call the sidecar is typically, Dapr runs on port 3500. So you would call localhost 3500, and then the API. In this case, I want to call the invoke API, which is the synchronous request reply API. Then you see I have the name of checkout, that's the target service, and the order method, which means it will call /order. What will happen in that case is the Dapr sidecar next to shopping cart first will use its discovery method to find out where is the checkout service. Once it finds that, it will call the checkout service sidecar. The checkout sidecar will check if the shopping cart is allowed to call the service. It will, pass all the traces, populate those, and call the checkout service on /order. If you get back a successful response, then the checkout sidecar passes the data back, and it reaches the shopping cart service. There are other things happening there. For example, if you enable MTLS, all the traffic between the sidecars will be encrypted. If something goes wrong and you have resiliency policies, those will be applied, right? So you get all of those benefits. And how do I do that call? Now, I don't have Java examples. I just have .NET, Python, and various others. But in this example, I have in this example, it's using the .NET Dapr SDK, and you see it's quite straightforward call with the name of the target service and the endpoint. If I want to do the same, let's say in Python, in this example, actually, I'm demonstrating two things. One is not using any SDK, so it uses Python's native HTTP calling capability. And the second thing is I am passing the target application name as a header. You see there is a header that says Dapr app ID checkout. So that's another way. If you don't want to use the Dapr's API with v1 checkout method, etc., instead you can just pass a header. So this is less intrusive way of passing the target application name, and you call the sidecar localhost 3500 /order. That sidecar will make sure the request to /order reaches the target destination with the checkout service. So this is how you would use the service invocation. Now, why would you do all that? One thing you can do, for example, then is I can now start constraining who can call the checkout service. Maybe I want to allow only to the shopping cart app, right? And here, you see, I'm applying a configuration to the checkout app, and I'm saying, by default, deny all access. So by default, you're locking down everything. And then further down, I am only allowing the shopping cart service to make HTTP post request to /order. So that's the only allowed operation to checking cart app. And no other app using Dapr can access checkout service. Once I secure access, the other thing I can do is, for example, I can add a resiliency policy, such as retries, timeouts, and circuit breaker. And in this case, I'm adding a circuit breaker to the shopping cart app. Basically, what I'm saying is shopping cart app, when you are calling checkout, right? If there are more than 5 consecutive failures, stop passing the request to checkout app for 60 seconds. And only after 60 seconds, pass at most 1 request to check if the checkout app is back and healthy. Right? This is a typical circuit breaker, but because it's happening at the sidecar, that means it is working with any kind of framework, any language. It works the same way. And similarly, you can configure here a timeout or a retry if that's safe, etc. So to sum up, to use the service invocation, you only change the source application. You need to pass, the the target application as a header or as a URL, and you just call the sidecar. The rest happens, or there is no further, any kind of intrusion to your application. The rest stays the same. And on the target application, you don't have to do anything. It gets sidecar injected, and you don't need any code changes. With that, you get, all kinds of service discovery. Well, for example, you can use HashiCorp console. You can use a database to discover services. You can encrypt the traffic. You can apply access policies. You can even intercept all the calls and plug in, something like OpenID Connect, run WASM scripts, etc. So you can intercept all the interactions. That was basically the simplest, right? How do I do a request reply? But once you start increasing the load, whether that's the number of applications or the number of users on your system, you start facing other challenges. For example, how can I make the application more responsive? Maybe when the user interacts, I just want to return back quickly a response and process that downstream asynchronously. How can I decouple the lifecycle of the services and their dependencies? How do I protect the downstream services from any kind of spike in the load, right? And the answer to all of this is put a message broker, right? That's the default answer. And to do that with Dapr, right, the whole idea is if you have some kind of a message broker, the first thing you do is we create a component for that message broker. Here I'm calling, this will be my order pops up. Yes, this is the component YAML file. I'm saying, okay, it's a type of Redis. And after that, I have Redis-specific configurations. Basically, how do I connect to Redis, right? The important thing here is the name, order pops up. From this point on, I can now, if I use Dapr on the publishing side, the checkout service, again, calls the sidecar on localhost 3500. But this time, instead of invoke, I'm using the publish API. That's why you see the word publish there. Then the name of the component, order pops up, and then the name of the topic. With that, the sidecar on the checkout service, when it gets the request, it will wrap the request in cloud events format. That is a common, quite popular envelope format for events. It helps further down, for example, for filtering and things like that. And the sidecar will deliver the message to the message broker. Of course, before doing that, it will check if this checkout application is allowed to publish to this message broker. Is it allowed to publish to this specific topic, for example? If that publishing fails for whatever reason, you again can apply resiliency policies. So resiliency policies are not only for service-to-service communication, but also when communicating with other components like message brokers, databases. If that's on the cloud, for example, you can retry publishing, etc. And the message will eventually reach the message broker. And I think on the consumer side, there is again, Dapr will pick up the message and it will deliver it to your application on a specific endpoint. And here I would say the more interesting part is how the consuming happens. And it can happen in two ways. The first one is you can subscribe. Here I'm using Python, but I think the more interesting part is that you are consuming messages with the push-based approach. So when I say push-based, think about how Amazon Lambda delivers events to your function, right? When Amazon Lambda gets an event, it does an HTTP post call to your Lambda, to your function. And this is how Dapr push-based approach delivers these messages to your application. In this case, Dapr will do an HTTP post to /orders. And if you see the code, the Python code, actually there is nothing about pops up in it, and there is no even Dapr SDK. It just starts an endpoint on /orders that for the post method, right? That's all you need, and Dapr will do a post for every message. And if for any reason that post call fails, depending on your resiliency policies, it will retry. And if that post still fails, eventually the message can even move to DLQ. And that's the post message. So your application really doesn't have to bother about opening up connection, keeping the connections, confirming messages, etc. It just handles an HTTP request. There is also the pull-based approach, which is the more traditional messaging approach. In this case, I have a Go sample, which is using the SDK. You see there is a new Dapr client created, and it subscribes to order pops up to orders topic. This is probably the more familiar approach when you are using messaging. The only difference in this case is your application is not connecting all the way to the broker, it's connecting to the sidecar, and it's pulling the messages, and the sidecars make sure that the messages are delivered. That's the difference. On the publishing side, it's quite straightforward, very idiomatic way of publishing messages to any kind of message broker. The fact that it's just a Dapr client and you are publishing to the sidecar rather than connecting to concrete messaging system. And if you add Dapr into the mix and use Dapr to talk to a message broker, some of the things you can do with that is, for example, you completely can hide the actual semantics of the underlying message broker, right? You can use pull or push. You can do content-based filtering. For example, you can route different messages to different apps, different endpoints. You can also do aggregator splitter. For example, maybe you want to aggregate 10 messages and then join them together and only then send to the message broker on the publishing side. And on the consumer side, you consume the message, you split it, and deliver each message independently. So you can do all of these things. If the underlying message broker doesn't have a native DLQ, like maybe Kafka, I don't think Kafka has a native DLQ, Dapr, for example, can make sure that any message that's not processed moves to DLQ. If the underlying message broker doesn't have message expiration, Dapr can do that. For example, it will make sure that no messages that have expired, that have a TTL, reaches the consuming application, etc. So you get all of these capabilities that might be missing on the underlying message broker. Now, that was PubSub. Next one is, let's say, accessing to state. I think all services, they need access to some kind of database, right? And some of the questions, for example, is, how do I control concurrent access? How do I expire data if it's used as a cache? How do I encrypt data before and after storing, etc.? And these are the things the state management API does. It's much more straightforward, and I think you're getting the idea now. I need to define the component for the state store. And in this case, very creatively, I called it state store, which is, again, using Redis in this case. Redis can be used both as a state store, and Redis stream can be used as a PubSub, right? And once I defined the state store, you see I can now start doing, create operations, read operations, delete operations, for example, using get. And what you get on top of these abstractions is you can control, for example, the concurrency. Do you want, for concurrent requests, should the first write win or the last write? How should the consistency work? Should it be, strong consistency, eventual consistency? That's dependent on the underlying data store. You can set, you can use the data store as a cache. Even the underlying data store doesn't have time to live. Dapr, again, can make sure that the records you put there after expiration, they never reach, they cannot be read, right? You can encrypt the data before sending to the data store and decrypt when you are reading. So all of that is happening in the Dapr layer across different kind of state stores. And I think the more interesting thing here is now you can start combining these APIs. And one of those interesting patterns here is the outbox pattern. Right? The idea of outbox pattern is, Gunnar is waking up. Yeah, is to when you are writing to a database, you're also writing to when you are writing, to a couple of tables, you're writing to a separate table called outbox with the intent of another process reading those and propagating to some kind of messaging system. And to enable this behavior in Dapr is quite straightforward. All you have to do is add those 4 lines. Basically, I'm saying when I'm using this MySQL component, right, in this case it's MySQL, every time there is any kind of update to the data, any kind of change, publish that change to this PubSub component to the new order topic. So what will happen is if your application is using Dapr to write to a database, Dapr will make sure that that change reaches also a message broker. And here you can see you can combine different kind of databases with different kind of messaging system and get basically the outbox behavior. And the next thing, I would say, not all services are stateless and can be scaled indefinitely, right? So there's always a couple of services that are stateful. Typically, they have some kind of business process. In this example, we can assume, for example, the checkout service. Maybe when it's processing, a shopping cart order, first it has to call inventory service to reserve the inventory. Then it has to call the payment service to authorize the payment. And if the payment succeeds, confirm the reserved inventory. Otherwise, release the inventory. And you want this behavior not to be only in memory, but you want it to be durable and persistent. Because if you restart the app, you want that process to continue and not have any inventory that's reserved but not sold, etc. The way to do that would be to use some kind of a Saga pattern, some kind of a workflow engine. And Dapr also has a workflow API. So the idea of workflow API, I'd say workflow is more than an API. It's also a programming model. For example, you can have a workflow as shown here. I'd say workflows are, let's clarify what's a workflow. When I say workflow, I mean a sequence, a collection of functions, which are called activities, as you hear A, B, C, D, a collection of functions that needs to be executed in particular order. They can be sequential, they can be in parallel, etc. And there might be some conditions, right? In this workflow, for example, I have the first thing is activity A. That activity gets a secret, calls to some system to get a password, right? After that, there is a waiting for an external event. That typically can be waiting for a human input. Maybe somebody has to approve this action, right? Once you get that approval, then you have activity B and C that are running in parallel. They are doing completely different things. And only when both are completed, there is activity D that sends a message, right? And if this is implemented with Dapr workflow, the whole execution gets persisted to the state store, to a database. That means it runs, when it started, it runs asynchronously. It can run, for hours, days, years, it doesn't matter. And it will run in a durable, reliable way. So if you restart to something, it will continue, right? And you can define those in different languages using the SDK. So the first thing is you define the workflow, and then you start it. And you can see the API below how to start that. It's the 3500/workflow, and the name of the business process, and start, and that will start it. Yeah. So when you're using workflows, you can create different kind of patterns. For example, I'll look at 4 patterns. The common one is the sequence, where you have a chain of couple of actions that needs to be executed in sequence, but only, the next one starts only when the previous one finishes, typically because there is some kind of a dependency in the data you're passing. In this case, I need first to execute activity A, get the result from that, execute activity B and C. And these executions, they are not just in memory, right? All stages are stored in a database, and they're executed in a reliable way. Another pattern is split synchronize, right? The idea here is I'm getting a set of tasks that are not defined in advance. You see, I got those with get work batch. Then I want to run all of these tasks in parallel, and where I'm scheduling those activities. And only when all of the activities have finished, the process will wait for all of them finish, and this can take different times. For example, if one of those activities is taking considerably longer, in this case, it will wait for all of them to finish. Only then the whole business process will finish. That's the split synchronized pattern briefly. And there are others, right? For example, another one is external trigger, when you want an external event to come and approve the workflow and continue. Another one could be timer. You can have some kind of delay between the tasks. You have a function here. You have an activity that after that activity finish, you have some kind of timer. For example, you can say here, wait for a couple of minutes, or don't execute it until a specific amount of time, and then workflow finishes. And you can schedule that workflow to start again as a brand new instance. So these are typical common workflow patterns, and you can define those using the DSL in different languages. Once you define the workflow, you have a number of management things you can do. For example, you can start that workflow. This is when it starts executing, and that, as I said, can take a long time depending what's your workflow, or it can be instant. You can get the details, check its status, suspend, resume, etc. But you can manage the workflow. This also brings us to this common question you get: should you use choreography or orchestration? And I think that different school of thoughts. Choreography is basically using event-based interactions between your systems, between your services, or within the service, and it has certain advantages. You can add more participants easily, but the disadvantage is you don't know what's the overall state, because that's all distributed between the events. And the other approach is using orchestration, which is basically using some kind of a workflow engine to orchestrate the interactions, as I showed you earlier. Now, when you're making these choices, you also have to pick different frameworks, right? For orchestration, you have to pick a workflow engine. For choreography, event-driven system. And these different frameworks, they have different programming models. They have different type of errors, etc. So with Dapr, you don't have to do this kind of choice. Basically, you can use one framework that can do both, and you have one way of, one SDK, one way of programming, debugging, and interaction. And typically, you may use, orchestration within the boundary of a single service, because you want to know maybe what's the status of the business process within the single service. And you use choreography when you have to coordinate the interactions between different microservices. And you can combine these easily with Dapr, right? So you don't have to pick one. And I think that's not the right question to ask. And there is more. I would say these are the most common APIs used with microservices. But there are other things you typically have to do. And this is not limited to microservices, by the way. This is valid for any kind of system. For example, very often you have to perform some kind of backup, right? At midnight, you want an app to copy files, to perform database dump, or every morning send emails. That is basically recurring tasks. And you can see here how straightforward it is, for example, to configure Dapr. In this case, it's called binding, a cron binding. I'm giving a schedule of 15 minutes. And every 15 minutes, this sidecar will call the application with the HTTP post telling it to do something, right? And you can use, you can make it daily, weekly, etc. The cron binding is stateless. So in this case, if you restart, or it will lose what has been run before. If you want stateful version, there is a jobs API, and the TLDR here is, it's again the sidecar is calling your application, but behind the scene, the jobs API will use some kind of a data store. In this case, it's etcd to store the jobs, right? And in addition to storing the job, it can also pass specific data. So in this example, I am configuring a job for backing up the database, but I can also give some kind of concrete instructions, some kind of metadata. And when this job is run, I think in this case, it just runs a minute after it started. It runs up to 10 times, right? The sidecar will call your app, and in addition to calling, it will pass the data you told it to do. Then your app can go and do its job, back up something or do something as a cron. Another thing, sometimes you want to protect access to certain sensitive resources. For example, if you have a file and you want only one app to read, right? You want to give exclusive access to only one process. Or for example, when you are consuming messages from a message broker, you want only a single consumer with a single thread to consume that, because you want the messages to be processed sequentially. And in this case, you can use distributed lock. So rather than inventing your own locking mechanism, Dapr has the distributed lock API. You see here, it's an alpha, so this is quite a new API. Basically, the whole idea is you can create locks, and If there are multiple applications or multiple instances of the same application that are competing for that lock, only one of them acquires the lock. That becomes almost like the master that can get access to the resource. And this application has continuously has to continue and renew its lock. Otherwise, it's assumed it's maybe the application is dead and another application will pick it. So behind the scene, this lock will be backed by some kind of storage, such as Redis. But from your application side, you don't have to do any kind of locking logic. You just call the Dapr API and get lock access. Other things, for example, configurations. On Kubernetes, these configurations, for example, can be backed by a Kubernetes config, but the same configuration can come from a database, or it can come from in this case, it says Azure app config, so you can use a cloud config. Your application can call the sidecar. In this case, you can see it's the configuration API, the name of the config, the key to get the configuration. Or if the configuration changes, the sidecar can push that change to your application if you want dynamic updates for configuration changes. Secrets is very similar to configurations. It works with different kind of secret store, and it doesn't have this dynamic updating. So you can only read, and if any secret changes, your application has to read it. It cannot push the changes to your application, but it gives you access to different kind of secret stores on cloud services. And what about AI? So I'm curious how many of here are doing something with AI, like using chat API, agents. Okay, 2 people, not many, but Dapr also have a conversation API. This is quite a new API. Basically, it gives you access to different chat models. You see which ones here, Anthropic, Bedrock, etc. That means you can use the whole tracing, authorization, resiliency features. Plus, on top of that, it has, masking of PII data, etc. But you can talk to various LLM APIs from the same system instead of adding different libraries. And lastly, agents. If you are actually developing agents, you can use Spring AI, you can use LangChain and Crew. So there are many frameworks. But Dapr also has for now, it's limited to Python, Dapr agent version, a Python version that helps you create agentic applications. So if you look into agentic applications, actually, behind the scene, they are distributed systems, right? They use messaging, they use workflow, state store, and this Dapr agent is a Python wrapper on top of the Python SDK that helps you create agentic applications that can interact with the LLM, call various tools, etc. So if you are into that, that's the URL to check. And lastly, I think the way I look at Dapr is almost like a cloud-native middleware. So I was just putting some examples here. For example, if you are writing a distributed application, what kind of things you would need? First, you would need some kind of a runtime, like Spring, Quarkus, depending on the language, it can be .NET, Django, etc. And Dapr has nothing to offer here. It doesn't run your application. As I said, it runs next to your app. But then you need the application to do synchronous calls. You need various HTTP, gRPC, REST clients, or maybe service mesh. Then your applications will need asynchronous calls, right? You may need a workflow for some of the applications, and there are different workflow projects, access to different data stores, cron. I used in the past, Quartz. You can use cloud services, etc., etc. You see there are resiliency libraries and so forth. And I think if you're using Dapr, you can get maybe 80, 90% what those libraries can give you. And you don't have to add all of those libraries. And you may have to do these kind of things for different languages, right? With Dapr, you get all of that for all languages, and it makes the whole operations and monitoring uniform. And closing thoughts, I think we see different languages now becoming popular in different domains. For example, Java is still the best for business applications. Python is becoming the de facto language for AI applications, Go for more low-level stuff, .NET for anything to do with Microsoft Cloud, etc. And I think as developers, you will end up using more than one language pretty soon, if that's not already the case. And I think Dapr really makes it kind of handles most of these cross-cutting concerns for all languages. So check it out. And if you want to check it out, that's the last slide. Here I have a couple of links. Basically, Dapr.io, where you can find all the others, YouTube channel, Discord channel, etc. That's all I have. Yep. Cool. Mm.